In the present video, we will see about simple harmonic motion. See in the diagram, this pendulum is oscillating and maximum amplitude traversed by the pendulum is A1. It is shown in this diagram. Gradually, motion of the pendulum decreases due to certain force, and that force is restoring force. So finally it decays up to the zero amplitude. A small displacement x from its mean position set up restoring force, and which is directly proportional to the displacement x acting in a direction toward the mean position. And thus this restoring force, suppose F is directly proportional to the x minus, that is the negative. So F is equal to minus kx, where k is force constant. Here negative sign indicate that force is acting against direction of displacement and trying to take it to its mean position or to its equilibrium position. Due to the restoring force, minus k into d2x by dt2 and acceleration m into d2x by dt2. According to Newton's second law of motion, F is equal to mass into acceleration, that is F is equal to m into a is equal to m into d2x by dt2. Suppose this is equation 1, and another force, that is the restoring force, will try to take that object to its mean position or to its original position. F is equal to minus kx. Suppose this is equation 2. From equations 1 and 2, we get equation 3 as m into d2x by dt2 is equal to minus kx. Suppose this is equation 3. This is equation of SHM. d2x by dt2 plus k by m into x is equal to 0. Suppose this is equation 4. d2x by dt2 plus omega square x is equal to 0. Suppose this is equation 5, where omega square is equal to k by m and omega is equal to under root of k by m, where omega is angular frequency. Solution of this equation, this differential equation, is x of t is equal to a sine of omega t plus phi. Now we will see about circular motion and simple harmonic motion. This is the circular motion and this is the sinusoidal wave as shown in this diagram. At a zero angle and at a certain angle, this is a anticlockwise movement of this circle like this we are considering here. So certain angle is suppose phi 1. Then corresponding to the simple harmonic motion, that particle is air. Again angle is increasing and it becomes 90 degrees. Then peak of the simple harmonic motion, that is the amplitude, is shown here. Again this circle is continuously rotating in this manner. So phi 3 is an angle made air, and another position in the sinusoidal waveform shown in the diagram is at this point. So this is the equivalence and corresponding to the motion of simple harmonic motion with the circular motion. Another angle is phi 4. See here, this angle and corresponding to the motion here. Phi 5, so air 90 degree like this. So this is circular motion corresponding to the simple harmonic motion, how that performs. Phi 6, this is the angle and correspondingly that simple harmonic motion is shown in this diagram. Now we will see linearity and superposition principle. The resultant of two or more harmonic displacement is simply the algebraic sum of the individual displacement. Already we have seen displacement is x of t is equal to a sine of omega t plus phi, which is suppose equation 1. Suppose x of t1 is equal to a1 sine of omega t plus phi 1 and x of t2 is equal to a2 sine of omega t plus phi 2. These are the different amplitudes a1, a2. We can take a, b also. And initial phase difference phi 1 and phi 2 here. Now sum of the two views. The resultant of two or more harmonic displacements is simply the algebraic sum of the individual displacement. X of t is equal to xt1 plus xt2 is equal to a1 sine of omega t plus phi 1 plus a2 sine of omega t plus phi 2. So this is the superposition. This is one waveform and this is another waveform. And resultant amplitude is shown here with a capital R. These are individual amplitudes A1 and A2. Apply sine of A plus B identity. We will get sine of A, sine A cos B plus cos A sine B. According to that, A1 sine of omega t cos phi 1 plus A1 cos of omega t plus sine phi 1 and A2 sine of omega t cos phi 2 plus A2 cos omega t into sine phi 2. See here. Here cos phi 1, here cos phi 2. A sine of omega t, A sine of omega t. A1 cos of omega t into sine phi 1, A2 cos of omega t sine phi 2. So A1 cos phi 1 plus A2 cos phi 2 into sine of omega t plus A1 sine of phi 1 plus A2 sine of phi 2 into cos omega t. This A1 cos phi 1 plus A2 cos phi 2 is R cos delta. Sine of into sine of omega t plus A1 sine of phi 1 plus A2 sine of phi 2 is R sine delta. A1 cos phi 1 plus A2 cos phi 2 is equal to R cos delta is suppose equation 6 and A1 sin phi 1 plus A2 sin phi 2 is equal to R sin delta. This is suppose equation 7. Now R cos delta into sin omega t. R sin delta into cos omega t. Finally, x of t is equal to R sin of omega t plus delta. So this is the equivalence of the individual simple harmonic motions equation. Square equation 6 and 7 and add. A1 cos phi 1 plus A2 cos phi 2 bracket square is equal to R cos delta bracket square. A1 sin phi 1 plus A2 sin phi 2 bracket square is equal to R sin delta bracket square. So R square into bracket cos square delta plus sin square delta and value of this is 1 is equal to R square is equal to A1 square cos square phi 1 plus A2 square cos square phi 2 plus pi 7 into A2 cos of phi 1 into cos of phi 2 plus A1 square sin square phi 1 plus A2 square sin square phi 2 plus pi 7 into A2 into sin of phi 1 into sin of phi 2. R square is equal to A1 square into bracket cos square phi 1 plus sin square phi 1 plus A2 square cos square phi 2 plus sin square phi 2 plus pi 7 into A2 into bracket cos of phi 1 into cos of phi 2 plus sin of R square is equal to A1 square into bracket cos square phi 1 plus sin square phi 1 plus A2 square into bracket cos square phi 2 plus sin square phi 2 plus twice a1 a2 into bracket cos phi 1 into cos phi 2 plus sin phi 1 into sin phi 2. Suppose this is equation 12. Cos square phi 1 plus sin square phi 1 is 1 and cos square phi 2 plus sin square phi 2 is also 1. So therefore capital R square is equal to a1 square plus a2 square plus twice a1 a2 into cos of phi 1 minus phi 2. This is suppose equation 13. From this R is equal to under root of a1 square plus a2 square plus twice a1 a2 into cos of phi 1 minus phi 2. This is suppose equation 14. Now find resultant phase of motion. R sin delta divided by R cos delta is equal to tan delta is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. Therefore, delta is equal to tan inverse of into bracket a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. Now some of the special cases regarding change in phase. When two simple harmonic motions having same phase, so delta is equal to phi 1 minus phi 2 is equal to twice n pi, thus n is equal to 0, 1 and cos n pi is equal to minus 1 raised to n. So therefore cos of phi 1 minus phi 2 is equal to 1. So therefore R square is equal to a1 square plus a2 square plus twice a1 a2 into cos delta. So therefore R square is equal to a1 plus a2 bracket square. So therefore capital R is equal to a1 plus a2. If delta is equal to phi 1 minus phi 2 is equal to twice n pi. See here. See amplitude a1, amplitude a2 and this is the resultant of both a1 and a2. See here. Now when two simple harmonic motions having opposite phases, delta is equal to phi 1 minus phi 2 is equal to twice n plus 1 pi where n is equal to 0, 1. So therefore cos of phi 1 minus phi 2 is equal to minus 1. So therefore value will be R square is equal to a1 square plus a2 square plus twice a1 a2 into cos delta. So therefore R square is equal to a1 minus a2 bracket square. This is a1 and this is a2. So resultant is this green line. R is equal to a1 minus a2. Two perpendicular simple harmonic motions. Displacement of two simple harmonic waves are simultaneously perpendicular to each other. They are traveling along x and y directions and mutually perpendicular to each other as shown in this diagram. So this is one of the waveform and this is another waveform which having amplitude b and this having amplitude a. So x of t is equal to a sine of omega t plus phi 1 and y of t is equal to b sine of omega t plus phi 2. So this is this wave and this is this wave. Use trigonometric formula which is given as sine of a plus b is equal to sine a cos b plus cos a sine b. X by a from this equation 1 is equal to sine of omega t plus phi 1 is equal to sine omega t cos phi 1 plus cos omega t sine phi 1. This is equation suppose 3. Again from equation 2nd, y by b is equal to sine of omega t plus phi 2 is equal to sine of omega t cos phi 2 plus cos of omega t sine phi 2. Equation 4. So multiply equation 3 by sine phi 2 and multiply equation 4 by sine phi 1. So we will get x by a into sine phi 2 is equal to sine of omega t cos phi 1 into sine of phi 2 plus sine of phi 2 into cos omega t plus sine phi 1. This is equation 5. Y by b is equal to sine of omega t plus phi 2 is equal to sine omega t cos phi 2 plus cos of omega t into sine phi 2. This is suppose equation 6. Now subtract equation 6 from equation 5. We get x by a sine phi 2 minus y by b into sine phi 1, and which is equal to sine of omega t into bracket cos of phi 1 into sine of phi 2 minus cos of phi 2 into sine of phi 1. This is equivalent to sine of phi 1 minus phi 2. Therefore, is equal to sine of omega t into sine of phi 1 minus phi 2. This is suppose equation 7. Sine of omega t into sine of phi 1 minus phi 2. This is equation 7. Square equation 7 on both sides, we get x by a into sine of phi 2 minus y by b sine phi 1 bracket square is equal to sine square omega t sine square of phi 1 minus phi 2. So after simplifying this and making square, so we will get x square by a square sine square phi 2 minus 2 into xy divided by ab into sine of phi 2 into sine of phi 1 plus y square divided by b square into sine square phi 1 is equal to sine square omega t into sine square of phi 1 minus phi 2. This is equation suppose 8. Now multiply equation 3 by cos phi 2 and multiply equation 4 by cos phi 1. Square equation on both sides, we get x square by a square into cos square phi 2 minus twice xy divided by ab into cos phi 2 into cos phi 1 plus y square divided by b square into cos square phi 1 is equal to cos square omega t into sine square of phi 1 minus phi 2. This is suppose equation 9. Add equations 8 and 9, we get x square divided by a square plus y square divided by b square minus twice into xy divided by ab into cos delta is equal to sine square delta. Now certain cases are there. If phi 1 minus phi 2 is equal to delta is equal to 0, then x square divided by a square plus y square divided by b square minus 2xy divided by ab is equal to 0. From that, x divided by a minus y divided by b bracket square is equal to 0 plus minus x by a minus y by b is equal to 0. So this is the straight line, quadrant 1 and quadrant 3. X by a is equal to y by b minus x by a is equal to y minus y by b. Now second case, if phi 1 minus phi 2 is equal to delta is equal to pi, so sin pi, sin n pi, sin pi is equal to 0 and cos pi is equal to minus 1. So we will get x square divided by a square plus y square divided by b square plus twice xy divided by ab is equal to 0. X by a plus y by b bracket square is equal to 0. This is again straight line in quadrant 2 and quadrant 4. If phi 1 minus phi 2 is equal to delta is equal to pi by 2 and a is equal to b, then we got circle x square plus y square is equal to a square. That's it. Now frequencies are in the ratio 2:1. X of t is equal to a sine of twice omega t plus pi 1 and y of t is equal to b sine of omega t plus pi 2. Suppose this is equation 1. Use sine of a plus b is equal to sine a cos b plus cos of a sine b. This identity. X of t divided by a is equal to sine of 2 omega t cos pi 1 plus cos of 2 omega t into sine pi 1, and y by b is equal to sine of omega t cos pi 2 plus cos of omega t into sine pi 2. This is equation 2. We know sine 2 theta is equal to 2 sine theta into cos theta and cos 2 theta is equal to 1 minus 2 sine square theta. So x by a is equal to twice sine omega t into cos phi 1 plus into bracket 1 minus 2 sine square phi 1 bracket complete into sine phi 1. So Putting these values, we will get phase difference delta is equal to phi 1 minus phi 2. Assume that phi 2 is equal to 0, then delta is equal to phi 1. X by a is equal to 2 sine of omega t into bracket 1 minus sine square omega t bracket raised to half into cos delta plus into bracket 1 minus 2 sine square omega t into sine delta. So from this, x by a into 2 sine omega t into bracket 1 minus sine square omega t raised to half into cos delta plus into bracket 1 minus 2 sine square omega t bracket complete into sine delta. This is equation suppose 4. And y by b is equal to sine omega t, that is sine omega t is equal to y by b. So put equation 5 in equation 4, we get x by a is equal to 2 into y by b into bracket 1 minus y by b bracket square whole of the bracket raised to half into cos delta plus into bracket 1 minus 2 y divided by b bracket square bracket complete into sine delta. So rearranging the terms, we get x by a minus sine delta plus 2y by b bracket square sine delta is equal to 2y by b into bracket 1 minus y by b bracket square raised to half into cos delta. Square equation 5 on both sides, we get this equation x by a minus sine delta plus 2 into y by b bracket square into sine delta whole of the bracket square is equal to 4y square divided by b square into bracket 1 minus y by b bracket square into cos square delta. X by e minus sine delta plus 2 into y by b bracket square bracket complete sine delta whole of the bracket square is equal to 4y square divided by b square into cos square delta minus 4y raised to 4 divided by b raised to 4 into cos square delta. Squaring this equation, that is the left hand side equation, and rearrange on both sides, we get x by a minus sine delta bracket square plus 4y raised to 4 divided by b raised to 4 plus 4xy square divided by ab square into sine delta minus 4y square divided by b square is equal to 0. This is suppose equation 9. X by a minus sine delta bracket square plus 4y square divided by b square into bracket y square divided by b square plus x by a into sine delta minus 1 is equal to 0. This is suppose equation 10. Phase difference delta is equal to phi 1 minus phi 2. So put the value of phi 1 minus phi 2, that is the value of delta here. So we will get x by a minus sine of phi 1 minus phi 2 whole of the bracket square plus 4y square divided by b square into bracket y square divided by b square plus x by a into sine of phi 1 minus phi 2 minus 1 whole of the bracket is equal to 0. This is suppose equation 11. So from this equation 11, certain cases are derived. So for case 1, phase difference delta is equal to phi 1 minus phi 2 is equal to 0, comma pi. Then this equation becomes equation 11 reduces to x by a bracket square plus 4y square divided by b square into bracket y square divided by b square minus 1 is equal to 0. So waveform will be like this as you are observing the diagram. Now case 2, phase difference delta is equal to phi 1 minus phi 2 is equal to pi by 4. So that the equation 11 reduces to x by a minus 1 by root 2 bracket square plus 4y square divided by b square into bracket y square divided by b square plus 1 by root 2 a minus 1 is equal to 0. So delta is equal to pi by 4 and delta is equal to 3 pi by 4. So waveforms are like this as you are observing on the screen. From equation 11, case 3, phase difference delta is equal to phi 1 minus phi 2 is equal to pi by 2. Then equation 11 reduces to x by a minus 1 bracket square plus 4y square divided by b square into bracket y square divided by b square plus x by a minus 1 whole of bracket is equal to 0, and this is the waveform. So let's suggest figures. When two simple harmonic waves traverse from common point, then both the waves are perpendicular to each other depends their path on frequencies, amplitudes and phases of the individual waves. If the frequencies of two waves are not equal, then path traced by particle will no longer be ellipse. Then such curve is called Lissaj's curve. The shape of Lissaj's figure depends on phase difference and frequencies, also on initial phase difference. So these are the different figures. These are the Lissaj's figures you are observing in this diagram. So they are depending on amplitude, phase difference, as well as initial phase difference, frequencies, etc. So this is about Lissaj's figure.